7-5, operations with radicals. We're going to split this lesson into two parts. So today we're going to mostly focus on objective number 1. So we want to simplify these square roots. These look pretty familiar to us. However, they're not always perfect squares, which is the difference in this section. So if you look at the first one, the square root of 16, p to the 8th, q to the 7th. The square root of 16 is 4. And the square root of p to the 8th would be p to the 4th if we just cut it in half. But the square root of q to the 7th is not a perfect square because it's got an odd power up here. So how do we deal with that? Well, we know that the square root of 16 we said was 4. We know that the square root of p to the 8th is p to the 4th. And now in order to take a square root of a variable here, we need the power to be even. So how can I split this up? Well, I can split it up into a perfect square by taking the square root of q to the 6th times the square root of q. This means the square root of q to the 7th, but I've now split it into a perfect square. So what's the square root of q to the 6th, q to the 3rd, and now I've got my answer. 4, p to the 4th, q to the 3rd. That's everything we could simplify, and then I still have a square root of q yet that we could not simplify. Okay, so let me go through that one more time. We've got the square root of 16 is 4. The square root of p to the 8th is p to the 4th. And because this was an odd power, I needed to split it into a perfect square. And what that means is split it into an even power. So we've got q to the 6th times q. We know that the square root of q to the 6th is q to the 3rd, and then you leave the square root of q in your answer. Okay, so let's look at letter B. Very similar problem. We've got the square root of 36, x to the 3rd, y to the 10th. Well, the one that I need to worry about here is x to the 3rd. I need to split that up. So let me show you another way of writing it. We could leave the square root of 36 because that's a perfect square. Then you've got x to the 3rd. We need to split that into an even power, x to the 2nd times x. And then y to the 10th already has an even power on it, so that one's okay. We'll leave that one alone. Okay, now we want to simplify any radical that we can. So the square root of 36 is 6. The square root of x squared is x. The square root of y to the 10th is y to the 5th. And then what are we left with? We still have a square root of x that we could not simplify out of the radical. So here's our final answer. Okay, let's try these where we have some fractions under our radical sign. When you see this, if you can't simplify the denominator, we need to do what's called rationalizing the denominator. What I've titled up here, rationalizing the denominator. So let's just begin here by splitting up the top square root from the bottom square root. Now in the numerator, this is an easy one. The square root of x to the 4th is x squared. But in the denominator, I've got an odd power, so I need to split that up into the square root of y to the 4th times the square root of y. So I get y squared times the square root of y. Now the problem is we still have a radical in the denominator, and someone came up with the rule that in simplest form you never leave a radical in the denominator, so we have to rationalize the denominator. We don't want a square root in the denominator. Here's how you do it. If I want to cancel out the square root or get it out of the denominator, I'm going to multiply top and bottom by that square root. So if I multiply top and bottom by the square root of y, this will undo the square root in the denominator. The square root in the numerator is okay, so I'm going to have x squared times the square root of y. That's fine. In the denominator, here's what happens. When you take the square root of y times the square root of y, you get the square root of y squared. And they'd undo each other, and so we just end up with y. So what we get is a y squared times a y. These two together, when you multiply them, gives you y, because we get the square root of y squared. Okay, so then our final answer now, if you take y squared times y, our final answer becomes x squared times the square root of y over y to the 3rd power. Okay, so going through this one more time, you can separate the top and bottom. The square root of x to the 4th is x squared. The square root of y to the 5th we split into y to the 4th times y. The square root of y to the fourth canceled into y squared, or simplified into y squared. But then I had to rationalize the denominator because we don't leave a square root sign in the denominator of a fraction. So you multiply by the exact same square root. So the square root of y on top and bottom. When you multiply two square roots, you get what's underneath the square root here. And then we combine these together into y to the third. That was our process. Let me show you one more example here with letter B. This time we're taking a square root and we have odd powers in both the numerator and the denominator. So let's go ahead and split those up right away. M to the 9th, I want to split into m to the 8th times m because I want an even power here. In the denominator, I'm going to split n to the 7th into n to the 6th times n. Now, let's take whatever square roots we can. The square root of m to the 8th is m to the 4th, but I still have the square root of m left behind it. In the denominator, the square root of n to the 6th is n to the 3rd, and I still have the square root of n behind it. Okay? Now, do not leave this as your answer because we don't want to leave a radical sign in the denominator. So I don't really care about any square root signs in the numerator, but the ones in the denominator I need to get rid of. So I'm going to multiply top and bottom by the square root of n. Because I'm multiplying by the same thing on top and bottom, I'm really just multiplying by 1. If you put the same factor on top and bottom, you're really just multiplying by 1. So I'm not really changing the value of this, but it is a good way to simplify. So then the square root of n times the square root of n, that's the square root of n squared, or n. So we just get an n there. What do I have on the top? Well, when I multiply these square roots, I can put them together and under one symbol. So I have an m to the 4th, and then I have the square root of mn, rewriting it as one square root. And then in the denominator, I've got n to the 3rd times an n, so that's n to the 4th. This is what we're left with. Okay? So canceling out that radical symbol in the denominator is what we call rationalizing the denominator. Finally, let's go ahead and multiply two radicals. What's your strategy here? Well, in order to even do this, you have to have a like index, what we call the number out in front of your radical sign. This is called the index. So because these are both 3's cube roots, I can multiply them together. Or in letter B, because these are both 4th roots, then I can multiply them together. They have to be the same index. Okay, so what's the method here? Well, if you see the numbers out in front, I've got a 6 times a 3. You can start there. 6 times 3 gives you 18. Then you want to multiply everything underneath this cube root sign, and you can keep the cube root here. So we've got 18 out in front. 6 times 3 is 18. And then under the cube root sign, we're going to multiply 9n squared times 24n. 9 times 24 gives me 216. N squared times n gives me n to the 3rd power. Now that we've got these multiplied together, I can go ahead and simplify my cube root. So simplifying here, I've got an 18 out in front, don't forget about that, times, now what's the cube root of 216? The cube root of 216 is 6. And I can also take the cube root of n to the 3rd, I get n. And now I just want to multiply 18 times 6 and I'll have my answer. 18 times 6 is 108, so our answer is 108n. Let me show you another example in B here. So we want to multiply two radicals. They have matching 4th roots, so that's good. Let's start with the numbers out in front. 5 times 4 gives me 20. Now we can put the 4th roots together. We can multiply them together. So I've got the 4th root of, now I need to take 24x to the 3rd times 54x. Doing that math, I get 1,296 x to the 4th power. Okay, now let's take our 4th root here. I've got a 20 out in front. The 4th root of 1296 is 6. And we know that the 4th root of x to the 4th is x. So 20 times 6x gives me 120x. All right, now This you would definitely do on your calculator. The fourth root of 1,296, do that on your calculator. So these are pretty easy if you understand which numbers to multiply together. Here's one for you to try on your own and bring it to class with you.